Hello everyone, it's December 17th. We are early today. If you take a look, we have still 11 minutes left. So I'm gonna just do the other one first and then we go back to do what we're supposed to do today. I'm also setting up my other laptop. I'm installing the new Mac OS Monterey. So I was hoping by the time I set up the other laptop, I can use the other laptop to do the streaming. I think the other laptop is newer than this one, the current one I'm using, although it doesn't have as much memory or storage. But I mean, judging from what we have experienced, right? This is super slow whenever I'm streaming. That means what I think is the CPU is too slow, because this laptop currently I'm using has 16 gigabytes, right? And as I'm streaming, it doesn't really use all the memories. Like I have a live memory count. It's currently at 19% left, right? So it's not the memory issue for all the slowness. It's most likely, I think, is a CPU issue, because this laptop is 2015, so it's old. It's old. All right. Anyway, so let's go for it. So this is, oh my goodness, people hated this question. Suppose we have a file system that stores both files and directories. An example of one system is represented in the following picture. Directory, subdirectory. Oh my, oh my. We have dir as the only directory in the root, contains two subdirectories, sub1, sub2. Sub1 contains a file and subdirectory. It's like a sub, right? Sub2 contains a subdirectory and a file. In text format, it looks like this. The tab character. If we were to write this representation in code, it will look like this. So every file and directory has a unique absolute path, which is the order of directories that must be opened to reach the file directory itself, all concatenated by what? The absolute path. Oh, by the. Wait, is that a slash, right? Yeah, that's a slash. That's a backslash. So file 2 will be directory slash sub slash sub slash Each directory name consists of letters, digits, and or. You gotta be kidding me. And or spaces. It has spaces in it. Each file name is of the form name.extension, when name extension consists of letter, digits, and no, like extension has spaces in it as well. Oh my god. Given a string input representing the file system, return the length of the longest absolute path to a file in the abstracted file system. If there is no file, return 0. So this one written. Oh, that's not how many. It's, wait, 20. And the absolute, so of a file. So the folder doesn't count. Length 20 is how many, what? The longest absolute path was it 20? 1, 2, 3. Do we count this? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so first of all, why? Why you return the number? You just return the directory, right? Oh my god, I have 2 files. So it's not necessarily the deepest, right? If I have a folder that has 100 letters, and that one will be used. Oh my. File, and long file. I think that's long file. Oh wow. New line, character, a tab, a dot, and a space. Oh my goodness, the input. Oh, all right, so we have to handle the input first, right? And then what? I mean, we can build like a tree, right? We can build a tree out of it. But we need to, oof, how do you build a tree out of it? It's like I can visualize it, right? You visualize it, it will be easy to understand. But if you try to, I actually don't know. I mean, I just play around with this. So we have dir, and we have a new line and a tab. Then we have sub dir1. Okay, so that's dir, new line, and a tab. So whenever there's a tab, that means it belongs to the one above it. Okay, so sub direct 1. And then we have a new line and a tab. We have sub dir2, a new line and a tab. A new line and a tab. Oh, I'm gonna I'm gonna flip out. It's a tab because every time a new every time a new line, it really is a new line. So sub directory 2 is here, and then tab, a new line, tab, and then that's our actual file. What do you think? Well, first of all, I don't think we need to build a tree because, like these files, if we take a look at example 2, right, directory tab, so we know this is under directory, and I tab, so that's 2 tabs. That means this belongs to here. That's a file. And then tab, that's a directory, also belongs to here, right? And then, so we'll get a file, we'll get a value already. And 1 tab, so 1 tab, it doesn't belong to this, it belongs to this, right? And so every time we have 2 tabs, that will a stack, right? So directory, I push into the stack, and if it's just a new line, but without a tab, that means nothing is under this. So I just pop it and then get a new one. Okay. How do I know that a file has ended? It's we'll see. So directory was in a stack. New line and tab. So this push onto the stack. This one push onto the stack. New line and a tab. The tab is 2 tabs, right? 2 tabs. So we check. So we count how many tabs there are. If it's the same number of tabs, that means this one is the same level as the previous one, which means the previous one has already done, right? Okay, so this time I have 2 tabs, and we check the previous one. I check how many is in the stack. So we have 2 in the stack, and we have 2 tabs, which means it's good. So I know I can push this one to the stack. So after we push to the stack, then we're going to check the last item. If the last item has an extension, which means it has a dot, and that's a file. And then the current length of, well, not the current length, the current the total length of the digits, no, the characters inside the stack will be the length of the file. All right, and once the file is done, if it's a file, we just pop it. Now I come back, we have one tab, right? So we go into C, one tab, but now it has two, right? The stack has two. Then I know we need to pop this one, pop the last one, and push this one in. So this one got pushed in. No. No, that's two tabs. My bad. I didn't see that. That's two tabs. Okay, so I pop this one out. Yeah, because we'll handle everything. And when we have a new thing, this is all already done. So I have two tabs. We check the size. Size is 2, so that's good. So this one pushed in, right? And then we're done. Now, when we're done, the next one has one tab, right? And then this one we check. Oops. Oh, now we can just keep pop until we have only one left. So until one on direct left, so this one will pop, push in is here. Tap, tap. Okay. I might have an idea. So let's go for it. Wow, imagine I'm setting up the new laptop and trying to do this. But the thing is, all the system I have with all the tools I'm using and all the shortcuts and whatnot, it took a long time to get these things together. So honestly, it's what the hell? Oh, it's not. My bad. It's lead start. Yeah, like it took a long time to set up everything. So I'm actually not sure if I can set up the other one the same way as this one. I wish I can have like a magical button, right? That's all we need, a magical button. And you press it, and it will just give you all the setup that you like. I mean, is this the best setup? Probably not, but it's a setup that I like. All right, so I will use this as an example. All right, so what we're saying, so we need a stack, right? We need a stack. That's fine. And then I'm going to start reading. How do we read? That is a question. I want to read a line by. I cannot read a line by line, right? How do we read? I mean, we can. New line, right? New line. Let's split it by new line, okay? If we split it by new line, can we even split by new line? All right, I'm going to have to, this one will be tested in a very different way. All right, I like this example. This is a very comprehensive example. I like this one better than the first one. All right, I'm going to have to do a lot of trial and error. All right, so this is this, and what's the answer for this one? This one answer is 32. Okay, 32. All right, just using this, and we're gonna give it a shot. Input length input. All right, it's not gonna be correct, but I just want to see what would if I input dot. If I go print. Right, input dot split. Split on this. What is going to happen? Oh, it works. It works. And then what? Can I count how many tabs there are? I mean, So everybody shall have a leading tabs. So I need to count. Can I count? Let's say print. Let's say input split, right? Split equals this. Okay. Then we say input split 1. So we're looking at this one. Dot count. I'm not sure what's gonna happen. Do we have 1? Oh, print, man. Hey, it works. All right, let's see. 1, 2, 3, 4, 5, 6. Let's try 6. That's 3. Oh, I can just count. Well, that's neat. That is neat. Okay, so what are we gonna do? What are we gonna do? So we split the input, right? And then what? Then we're gonna say for item in input split. Well, I actually just do this and save one, right? I also want a result res 0, right? And now we say for the input count how many tabs is in front. So num tabs equals it dot count tabs, right? And we say while len stack is larger than num tabs stack dot pop. So we pop until with the same number of tabs. And when that happens, stack dot append the current it. Now it's going to be it something to the end. What is this value? Now this value is num tabs times 2, right? Because num tabs have 2 characters. So for this, it'd be 0, 1, 2, 3, 4 to the end. So we append this to it, and then that's it. Now, for each coming out, we need to first check. Well, actually, no. I actually don't like it. So we are going to, you know what? Yeah, that's fine. That's fine. So we push it in, and that's it. So every time a new one needed. So when do we check? When do we check? Oh, we check right here. Append, right? So we appended it. Now we're gonna check. So check for file, right? How do we check for file? We just pushed something in. So we're just going to say if, okay, let me see the file name. What if the file name contains dot in it? Or what if the folder name contains dot in it? I don't really care about the file name. And then that is considered a file then. Each file, yeah, so dot only exists. So okay, so basically we just say if dot is in it, how long we have 10 to the 4th. We just might as well just check. So we'll just say if dot is in it, right? So this is a file. This is a file, right? And I already pushed it in. Then what we do is res equals max res length, not length, sum something plus, because they have to be split by a slash. Which one is backslash? Yeah, this is a slash. So slash. So the number, so 1, 2, 3, 4 has 3 slashes. So it would be len stack, right, minus 1. And this is the total character count. And how do we do character count? Screw this. Screw this. What is the length? This join. Yeah, seriously, screw it. We're gonna join stack, and now we just get the length. That's it. If it's this, then this, right? And then we come back up, and then we just keep popping, keep popping, and then at the end we return rest. Okay, dokie, okie dokie. So I want to also check, which means I want to print stack every time this happens. So we run it. I have, ooh, what is this? Oh, this one counts as 1. All right. This seems to be good. All right, let's try the other one. Don't worry, we have bunch of test cases. We have, I think, 4 maybe. This one shall be 20. This one shall be 20. And what's the next one? Next one. This one shall be, wait, it shall be 0 because it is not a file, and this one is 12. I'm pretty sure there will be some edge cases that I fail. But so far so good. We're just gonna submit it. Oh, I just realized something. Tomorrow is gonna be a big day. Why? Because I'm going to do the contest tomorrow. Which could be a big day. We got this. I did pretty well. Give me some confidence boost, right? So the insight is that, there's actually a lot of insight. The insight is that each time a new line is encountered, new line is encountered, we will have to deal with a new item. The number of tabs determine to which previous item the current item belongs. It so happens that if we use a stack to keep track of the previous item, then if the length of the stack is equal to the number of tabs, then the current item belongs to the last item in the stack, or in other words, we can append the current item to the stack. If, however, the current item has has fewer tabs than the length of the stack, then the current item must belong to some item or not, right? Or no item before the end of the stack. Thus, we pop the stack until the size of the stack is equal to the number of tabs. Then we append the current item. To obtain the number of letters, characters, chars in an absolute path, we simply join the stack with separator set to the slash, and then count its length. All right, I'm pretty sure this one is it's ON. Well, ON. What do you mean by ON? From a split, and we do the, yeah, I think ON where n equal to line input. We hit 28 milliseconds or 82% ranking. Yeah, it's pretty good. Alrighty, go for discussion. See if there's anything interesting. Why do people don't like this question? I think it's good. That's a good use of a stack. Man, the brain power is completely different. Like right now, compared to like 9 p.m. 9 p.m. the brain is mushy. Like I don't even know I was talking sometimes. I just and now it's like I'm alive, right? I'm alive. All right, so the number of tabs is my depth. Split lines. Depth is using this. Good. Another way. Oh, so you're saying they're storing the path length. What does the dictionary do? Path length. Oh, the depth. Huh? I know this, right? So we split it by this, and every single one coming out, I use this to know the depth. All right? And then if this is a name, then we're gonna go path length, depth, plus len name. Otherwise, path length, depth, plus 1, and this one plus 1. Depth, 3 depth. But how do you know they follow the same thing? I can have 3 depth. What if I have 3 depths on top and have 3 depths at the second one? I know the depth. If it's this, then when you say the path length depth, oh, it's the current one. I see. This is the current depth, path length. Yeah, because we're constantly changing and we read it one by one. So we have a new depth. We will always replace it. Right? We'll always replace it. And 0 is 0. So if we get a new depth 0, so that's depth 1. So that will be, I see. I see now, I see. Well, technically speaking, I think this is faster because I'm repeatedly doing this, right? I'm repeatedly joining the stack. But hey, it works. It works. All right, that'll be it. Yeah, I don't want to spend too much time on this. Yeah, we got it. We got it. Maybe we can publish ours. What do you think? They all follow this Dictionary solution. Maybe we can do stack. I saw people using stack. Yeah, people are using stack. Yep, you see that? While this popping stack. Yeah, so nothing special. Nothing special. Python 3 stack. Oh, that's it. That's it. Okay, so we done this. Now we can go back. Let me check this one first. Now I can go back to do what tomorrow is going to be. So yeah, so I think what's going to happen is tomorrow I will. No, actually not tomorrow. I will. I think to do tomorrow I will. It's so today. So I'm solving the problem for tomorrow, right? I'm solving the problem for tomorrow. So tomorrow I don't have to solve it, so I can save all my brain power for 9 o'clock. I am not sure if that is a good idea though. So I mean, like Sunday we have the 2-2. We want to do it like late at night because I think it helps me manage my time better. I do it early in the day, and then I mean the thing is once I finish doing this is like a major brain drain, right? Once I finish doing this, I get tired, I get lazy, I just don't want to do anything, and then it's not a good thing if I drain my brain say early 11 a.m. in the morning, right? So I want 11 a.m. in the morning, I'm fresh, so I can do my other work. And this should be reserved at night, like 7 o'clock. 7 o'clock is a good time. Right, 7 o'clock is a good time. So I'm doing now for tomorrow, and tomorrow I am not doing for Sunday because if I do 7 o'clock, I do for Sunday, and I have to do it. You know what? That's actually fine. We can do 2 times. We just do one. 7 o'clock we do for Sunday, and 9:30. I think the contest is 9:30. So 9:30 I will do the contest, but I'm not gonna live stream my contest because that will look awful, right? And if I keep talking, that is going to affect the speed as well. Oh my god. It's a hard one, boys. I'm not afraid. I'm just worried. Oh man. All right, doesn't matter. I had a little hope. All right, it's gonna be an easy one. Well, might as well tomorrow be the easy one. Yeah, might as well tomorrow be the easy one. Have I done this before? Numbers at most n given digit set. So we give you some digit sets and ask you at most n. Yeah, don't guess. You don't know what this problem is about. All I know is it's just waiting and waiting and waiting. Yeah, I'm pretty sure like all the slowness is because of OBS. Because once I finish streaming, turn off OBS, and everything goes back to normal. It's so slow from time to time. It's just like OBS is a big kill, and so yeah, OBS is a big kill. It's like this laptop is only able to do one task at a time, right? So now, right now you can consider I'm doing 2 tasks, right? We have OBS is on, and we have Chrome is running like actively. So 2 things it cannot handle. And another time that it cannot handle 2 things when in a meeting I want to demo some app, right? So I have Google Meet on, and at the same time I want to run the app on React Native, but I can't. Just can't. The laptop just refuses to build the app. So this is just the current status of the laptop. I mean, what else can I say? We have solutions, so yeah. 902. Oh, I've done this before. Oh, they are recycling questions hard. Come on, man. Come on. That is not good. And I have solved this in the past. All right. Let's see. Given an array digits, which is sorted in non-descending order, which means we can have repeats, right? No, digits length is 9. Each one is 1. All values are unique. None is ascending. Okay. You can write numbers using each digit as many times as you want, well, actually you want. For example, if digits is this, we may write numbers such as blah, blah, and blah. Return the number of positive integers that can be generated that are less than or equal to a given integer n. I don't remember this question at all, which means it's either too difficult so it confuses me, or it means it's not that difficult and then I just blew past it. Okay, so if it's 100, but definitely we cannot do 4 digits, at most 3 digits. And because n is 100, so the first cannot be larger than 1, so only 1, right? And then the second digit must be smaller than 0, smaller or equal to 0, right? Wait, it's not equal to, less than equal to, right? So this one has to be smaller or equal to, so we find options. Now we don't have any options, so that's no-go. Okay, so we check the second one. So we have 2 digits, right? So 2 digits, the largest number is 99, right? So now we need to find how many numbers are smaller than 9. We have all of them smaller than 9. And because of 99, so that's going to be 1, 2, 3, 4. 4 times 4, that's 16, right? And then 1 digit, that's 4, that's 20. Okay. All right. So for this, again, same thing. Wait, is n is a regular any numbers, right? Yeah, n can be any number. All right. So again, the first one, I say anybody smaller or equal to 1. Yes, we have. Now look at the second one. Anybody smaller or equal to 0? Nothing. So this one is 1 times 0 is 0. Okay. Now starting from the second digit. The number of digits, right? So now we go for the second digits. And the second digit will always be 9, right? And then it's always going to be them multiplied together, right? So how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we have 9 digits, and each one we can pick 3. So that's 3 to the 9th power, right? And then plus 3 to the, 3 to the 9th power, 3 to the 8th power, 3 to the 7, 6, 5, 4, 3, 2, 1. 29523. All right, so I'm pretty sure we have a formula for this. So this is called, is that a geometric series? So we have, listen carefully, we have a to the 1, right? Plus a to the 2 plus da 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 plus a to the n. And we can do this. So Sn is this, right? So Sn minus 1 is a to the first all the way to a to the n minus 1. So n times Sn minus 1 equal to, no, a times equal to a squared plus all the way to a to the n. So a times Sn minus 1 minus, right, minus, no, wait, no, Sn minus a times Sn minus 1 equals a by itself. Therefore, now we try to find how to represent Sn. That's not right. Like how do you do this? Oh, my bad. I think yeah, so that's one, and the other one is Sn minus Sn minus 1 equals to a to the n. So we have 2, and I'm going to solve what Sn is. Okay, that's right. So Sn minus an equal to a. That's 1 minus a times Sn plus a to the n plus 1 equals to a. So we do an plus 1 minus a divided by a minus 1 equals Sn. Which is an minus 1 divided by a minus 1. Is that right? So 3 to the 9th, right? So 3 to the 9th. Yeah, might as well just use the other one. So just 3 to the 10. 3 to the 10 minus 3 divided by 2. 29523. That is correct. Okay. So let's do this. Yeah, this is not a difficult question. I can see why I was able to solve it last time. This is not a hard one. But there might be, I shouldn't say might be, I think there definitely is going to be some edge test case that I wasn't able to figure out. You see, I got 2 wrong answers in the previous time, right? That just means I was so confident, I was like, oh, this is a difficult question, and I think I got it. And then I was so happy. And then I do it, and boom, booyah. 2 things got wrong. 2 times, right? Wrong for 2 times. So how are we going to avoid it? Well, we are not going to avoid it for once, because what we're going to do is we are going to turn n into a digit, turn n into a what? Into a string, right? And then we're going to go from the left side, right? So we left side pop out, and we know, so we have the left side, right? And then, okay, now in this thing, we are not only dealing with like 1000 or 0 situation. You're going to be any number, any value. So the first digit come out, right? Then we're going to try to see if anything is smaller than it, right? So the digit come out, then we're just going to go, oh, because digits is only 9, so I don't want to do, we don't have to do binary search. We'll just go from first one and see how many there are that are smaller than this. We can use binary search. That's immediately. I give you immediate. Okay, we're going to binary search it. So then count how many are smaller than this value, right? So when we get how many there are, that's the first digit. Then that many number we can take, right? And then we go to the second digit to see how many it can take. Oh, shoot. So we have to go every single digit? Let me think. I mean, what we can do, hold on. So, if I have a value, let's say 456, right? And then at 4, I say, okay, I have so many values we can do on the first one. And then, if that value is smaller than 4, then the rest is like everybody is good. The only time that's not good is the first value is the same, right? If the first value, we can find it, then we have to go to the second value, right? And the second value, if it's smaller, if the second value is bigger than everything else, then we can take everybody, right? And once we take everybody, the rest can take everybody. But if this one cannot take everybody, it can take a few of them, all right? So we do a few of them. Then we look for the next one. So whenever it's the same, right? If it's, hold on, there are two scenarios. So first scenario is the current digit is bigger than all the other digits that I can find. Okay? The current digit is bigger than all the other digits I can find. Then that means all my digits can fit in there, right? All my digits can fit in there. And because my current digit is smaller than the current digit, then everything that I have can fit in there. So that's the easy case. So whenever we find a digit in n that is bigger than all the digits I have in digits, then all hell break loose, right? We're all good. Now, if the current digit is equal to, right, is equal to a digit. Let's say the current digit is 4, and my value is 1, 2, 3, 4, right? And then 1, 2, 3 is all hell went loose. It doesn't matter. You can do whatever they want, right? And that actually, yeah. So if the current value is 4, and I have 1, 2, 3, 4, so the only thing I need to worry is 4. And all the other values, because if it's 3, then it doesn't matter. I'm already smaller, so we can just do whatever I want to do. Okay? So, but if I'm 4, so I match, then I need to move on to the next digit and then see. Now, and the next digit, if it's smaller, right, then all hell breaks loose, right? So we can do all of them and then everybody else. But then that will be smaller. Yeah, that makes sense. And if we find something that's equal, right, that's equal, then we just keep moving forward, right? Keep moving forward. So these are considered as like different cases, right? The equal case are different. Okay. Now go back to the 1000. So we have a 1 that's matching, right? And there is nothing smaller, right? Nothing smaller. So on the 1. Now we move on to the next digit, is a 0. And 0 is a interesting case. Hold on, how do we handle these situations? Oh, so that's different. What we're talking about is if we have 4 digits, now we want to try to find all the 4 digits that's smaller, right? And once the 4 digits is done, then all hell breaks loose, right? Because my n is a 4 digits. Then it must cover 3 digits, 2 digits, and 1 digit. So the first thing I do is I can compute all the remaining values, right? All the remaining, it can be easily computed, just n. If n is a 3-digit value, right, then all the 2 digits and 1 digits is all hell break loose, so we can handle them immediately. Now we only need to handle the 3 digits, right? And with the 3 digits, the same thing. Now we go for the first. Now I see how it plays. Right now I see how it plays. So what do you want to do? We are going to handle the digits first, and then do all hell break loose. And all hell break loose basically is just when you use the same formula that I had earlier. So that's just one line, right? Okay, so we do have to str this. So nstr equals strn, right? This is important. And then we're going to just go for dig in nstr, right? So it's the first digit, and d equals int dig, right? Now we can try to find, but we can use from, it's called bisect, import bisect, go on the right or left? On the right. So if I do bisect right, then the return value is the number of counts, right? The return value is the count. Well, I mean, it's not exactly the count. So we need to have the index is equal to bisect right digits. Oh, screw me. Screw me, the digits is all str. And we can compare str directly, so why I don't need to do this. Wait, can bisect handle str? That's a good question. Nah, I don't want to do PT Python. It's gonna take like 5 minutes to turn on. I think it can, because bisect it must use the dunder LT function for this. And for strings, they do have the small or big things in it. So I think it's possible, but I want to verify it. But PT Python being PT Python, it'll take forever to turn on, which I don't even know why. All right, let's say 1. Right, so we have 1, 2. Let's go for a 9. Right, so this is sorted, and then we say from bisect import bisect right. And we do bisect right A3. How about that? It works. It does work. 0, 1, 2. It works. So I don't need this. So bisect right digits and dig. Right. So then we're gonna compare when you say, because that is the value that we want to insert, right? So we need to do this minus 1. So we say if digits index minus 1 is equal to dig. So this is the slightly complicated scenario, right? A slightly complicated scenario. We will handle this later. So I'm going to do else. Else is the digits I index minus 1 is not equal to dig. That means it's smaller than dig, right? So that means the index is the total number that's smaller, right? So what we're going to do now is going to do index, right, multiplied, right, by len digits, right? So len digits what? Times, because that's, we handle the first one, right? That's just first one. Oh, wait a second. That, hold on, let me think. If it's equal, then we don't handle. Equal, we don't handle, right? So if it's equal, we go to the next one. No. Oh, how do we do this? So if it's equal, then I need to go for the next one. But we also have something smaller, right? So those something smaller shall have this as well. What do I do? Alright, so I think what I'm going to do is I need a flag. Let's do a flag. Continue or be false, right? So if this, right, it means we have a match, right? We have a match. Then we say continue will equal to true. So I need to keep trying. But in this case, we're gonna artificially reduce index. Right? Reduce, actually it'll be easier if we do not use index, we say count. Right? So basically say, I have the exact same match, and then we'll handle this later. Okay, but right now, what we do is we will say count -1, so this remaining values, they can go haywire, right? They can go haywire. So now this is how haywire happens, right? Haywire happens. How did haywire happen in this case? Well, in this case, we know, so we do need an I, right? Went on to enumerate. Let's enumerate this, all right? And then count is how many I can take at the current digits, right? And then this will be the remaining digits that we can go haywire at it. And how many when they remove? When they remove I -1, right? Because if I is 0, that's the first digit, and the first digit we find something, and then we have a count, right? And then the total number of digits. Oh, actually no, my bad. This one is actually right, and this is the one. So len digits, right? How many digits and how many power is going to be len nstr, right? Len nstr minus what? Minus I -1, because I'm at the first one, so the remaining can do whatever they want, right? So that's that value, okay? And we are going to put this into a result, okay? So we're going to say res plus equal to this, right? Once it's done, now we go back. Actually, every single time I need to do this, right? So res plus equal to this, and then I'll say if not this, now we're going to break. Okay? Now we go back, now we go to the second digit, right? Now the second digit, again, we're going to count the second digit and this, right, to see if there's any matching. And then we say, boom, there is matching. And then we're going to count -1. Okay, count -1. And it could happen that the count is 1, right? Or maybe the count is 0. Yeah, what if the count is 0? Oof, the count is 0. Oof. So count can be 0 if the digit is too small, right? So we have to say if count is larger than 0, and if count is larger than 0, and it's going to count, and now we have a match, then count will do -1. Otherwise, count is 0, or if we don't match, that means the digit is bigger than, but the digit is in between, right? In between. Now we have a count, and then this count will be that, or times whatever is remaining, minus this is remaining, yeah. And then we will go back up, do it again, and do it again. Now we'll break out, right? So if every time we have something that does match, okay? So we have this match. If we match, we don't count this one, we count the one that's smaller, right? We count all the smaller, but not this one. The next one match, again, so we count the smaller. We count the smaller, yeah, so we count the smaller, basically this, we count the smaller, and then next one we count the smaller. Okay, so we keep going, and that seems to be right. That seems to be right. Okay. Let's leave as is. On breakout, what we need to do is to count everything else. All right, count everything else, which basically means the number of digits. So we're going to use the formula. So we're going to return, right, the result plus, okay, the formula. Okay, the formula. What is the formula? Okay, let's do this. Result m n. M is len digits, n is len nstr. Okay, so we don't have to do len digits anymore. That's just m. We don't have to do this anymore. That's just n. Right? Okay. So in this case, we're gonna do this divided by this, and that is m minus 1, and this is going to be m to the some power minus m. What is the power? The power is the largest power is going to be n minus 1. That is the largest power. That means if I have 5 digits, then everything is 4 digits is good. So it's n minus 1, and we're going to plus 1. So that's just n. Okay. Let's try this to see if it works. So we have 100 and this, I shall return 20. And this shall return 29523. And 7 and 8. I suppose this is an edge case. 1. Alright, and I'm going to remove these two. Oh my. How do I set that this has to be capitalized, like case sensitive? Doesn't matter. At most n digits and n. Pass, pass, and fail. Okie dokie. Because m minus 1. So what happens now is there's nothing, because I was saying gonna go to n minus 1. N minus 1 is 0, right? Because this handles 1 digit. Hold on. So what's m? M is the number of digits in this, right? N is this. So why does 1 fail? Because I had only 1. So what I'm doing is 1 to the 1th. I cannot do that. 1 to the 1 power plus 1 to the 2 power plus all the way 1 to the m power. Oh yeah, I cannot do that. It cannot be 1. So if m is 1, that is interesting. M is 1. The 1 to all these power would just be have the count times, that will be 1. So let's just plus equal to 1. And the next one we'll find the plus 1, plus 1, plus 1. So once we find everything, and then we need to count the last. How do we handle that? This is remaining, right? It's the same, it's just all ones. It's just all ones. So when you say if m equal 1, right? So this one is if m is larger than 1. Else, if m is 1, then we just return n minus 1, right? That's it. It's n minus 1. It's All right. Maybe we need this. There we go. Always about parentheses. Always about parentheses. Maybe I don't need this one though. Yeah. Okay. Let's give this a shot. I mean, we have a lot to test. This is to the 9th already. So we test this one already. We can do, let's do today's date, 12/17/1954. That's the current time. 1, 2, 3, 4, 5, 6, 7, 8. That's good. All right, let's see if we pass this. We do. How about this? How about this? Isn't this a edge case? Come on. This is the edge case. We pass this as well. All right, let's submit it. Let's hope that we do not have wrong answer. No wrong answer. No wrong answer. Come on. No wrong answer. Okay. Okie dokie. Okie dokie. You know what? I think eventually we'll find out that we fail on the same expected to. We fail on the exact same answer. What the heck is this thing? 3, 4, 8. Answer is 2. The result is 1. Well, that's 4, right? So count is continuous. So count is going to be, so I do digits is 4. And we did this, so it'll be 0, 1, 2. Count shall be 2. Count large equal to 0. And count minus 1 is 4 is equal. So continuous is true. Count minus 1, so count is 1. So 1 times 3 to the n is 1. That's a 0, that's a 1. So rest just count is 1. Result is 1. Basically, I do this. Now we go for the next digit. But we don't have the next digit. Yeah, I see. This is the case where we fail. Which means we always match, always match, always match, and we come out. And now that come out is continuous true, right? So it's so break else, all right? Else is this one and. Then if this one and I never break out, that means we have some value just it's all the same, all the same. So rest plus equal to 1. So this is we can form exactly n using digits. Right? Of course it passed. Now I'm worried. Now I'm very worried. But what I'm worried about, we're gonna have another wrong answer. And then we'll have that. Then we will not have improved. Come on, no wrong answer. No wrong answer. I'm worried. Oh, let's do this. 3, 4, 8, right? Okay. So 3, 4, and 8. And we use 3, 8, 8, 4, 3, 8, 8, 4 like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this. So that's the case that we have changed. Okay. All right, no wrong answer. Come on, let's do this. Yes, no wrong answer. So what do we say? We have improved. We got wrong answer once. Only once, okay? Only once. Any improvement is improvement. The time is fine. 32, 34 millisecond didn't really change too much. All right, we're gonna check the solution for sure. Whew. So old question again, but I like this one. I like this one. 902. All right, so this is 902. Well, we have done this before, and it seems like it was not too big a challenge back then. So the idea is the insight. I like to say insight. The insight is that say n has n digits, right? Digits. We only have to analyze n-digit values and analyze the possibility of forming n-digit values. We don't have to worry about n minus 1, n minus 2, to 1 number of digits, because any formation of these digit numbers will be smaller than n. Okay, so we evaluate n one digit at a time from left to right. Right. We try if a certain digit, if the current digit in n can be found in digits, and then we count, and then we must continue on to the next digit. Otherwise, we are done. Meanwhile, each time we analyze a digit, we find how many digits in the input array are smaller than the current digit. All of these smaller digits can form values smaller than n. Thus, at each digit, we will add a new count with the number of the smaller digits multiplied by any combinations of digits for the remaining positions. Right. We continue this until either the current digit is bigger than all the digits in the input, or n is exhausted. The trick that caused us an error, the thing that caused the error is that when n is exhausted is exhausted, that is we can find some combinations of the input digits to form n. We need to add 1 to the final result. Okay, what is the runtime? Well, the runtime is O